Доброго дня. Меня зовут Загрузких Евгений, я из Новосибирского.
I'm Evgeny Zagruski from Novosibirsk. I was speaking about development of public key crypto systems based on a generalized knapsack problem. IBM has developed a quantum cloud. What does it mean for cryptographic solutions? It means the changes of the cryptographic systems and the tasks as far as the quantum calculations. I would like to briefly remind you about the scales and the weights we have taken. In the early 1970s, Merka and Hellman had come up with one of the cryptographic solutions with the open key, and they used an additional number of weights. Each next weight is more than the sum of all of the previous ones. It is also one of the vulnerabilities of the crypto system. Such weights are allocated sparsely. Knowing that, what we need to know about the dependency? We need to know that all of the possible sums of all of the weights be unique, so that we will be able to use all these weights, and that's what we're going to do. We take a simple number of weights and take a zero, and take the next number. We add, update the sums, and I would like to give you a few examples. We'll start from 0, we'll take 2, we add 2, so it's 0, 2, we get 3 and 5 and so forth. Why do we need it? We have two crypto systems. We take this from linear programming. Why we need to have them? We have a closed key made out of it. The closed key starts from matrix B. It is made up by strings. There can be variable numbers and zeros. All the strings need to cover this system. And we can use it here. But we need to hide matrix B. We add new strings here. We know which strings we have added here, and we can resolve it in a minimal time. What we need to do next? We have an equals b. We have the maximum number on the right hand side, and we choose to make an H matrix which will be reversible. An open key here is the R matrix. So what's this encryption all about? It's the multiplying of the binary vector to the R open key. In terms of the hacker's approach, the number of equations is less than the number of the unknowns, and the unknowns are limitations. It's one of the tasks. Encryption is based upon reversibility of the H matrix. We have this BM equals B system. So we have this next approach based upon the IX equals B, but here we have the more homogeneous system, and we have the maximum number of the selection. For each of the solutions, we generate a random alpha vector, and we make the vectors that are open key. And so we have closed key, source matrix, for which we found linear dependencies, and the public key. We require to generate linear combinations of the vectors where we sum up the binaries. By multiplying the matrix, we have zero vectors, so we end up having the same system, AE equals Y. That's my presentation. I'm done. Your questions?
А вот в 2002 году там Куртуа.
In 2002, Courtois published some work about the algorithm. Did you apply such methods here? Courtois did that, and that work was quite interesting. So I ask a more general question. Did you use any specific measures to resolve it? We were just taking a look at how we restore the closed key from the open key.
Добрый день. А в чем преимущество?
What's the advantage of your advantage as compared to other standard ones? The resistance to a quantum attack, that's the difference. But mathematically,
Я понял. Все, хорошо.
Ну, для решения этих задач существует...
To resolve these tasks, certain algorithms allow us to do it in a minimal space of time.
Горячий Максим, Positive Technologies. Я прошу прощения, я пришел не с...
As far as I remember, there was an... Can you modify the Shamir's attack? I remember they were looking for that loophole, and we also did that, and we didn't do that. What would be the theoretic assumption? We could not get the proof of that theoretic assumption in practice. We didn't want to fine-tune it. We wanted to try that, but it did not happen. Thank you. Thank you for your presentation.
Следующего участника.